So we're going to talk about graphing logarithms. So just remember that this is log 2 of 16, which is the same as 2 to what equals 16, which would be 4, right? 2 to the 4th equals 16. And so this is similar. 2 to what equals 8. So 2 to the 3rd equals 8. And 2 to what equals 64. So that is 2 to the 6th equals 64. Okay? And so notice that these are all powers of 2. And this is really important, right? And that's because this 2 is down here. And this is going to be really important for graphing in just a moment. So we can write this function as y equals log 2 of x. And just so that you have some understanding, we can say that this function means 2 to the exponent y equals x, or 2 to what exponent equals x. All right, so this is, again, the inverse operation of taking an exponent. So if we wanted to graph that function, y equals log 2x, we first realize again that these x values are powers of 2. All right? So powers of 2 is 1/2, 1, 2, 4, 8, right? And so our y values are the exponents that give us this product. So 2 to the negative 1 gives us 1/2. So our y value is negative 1. And 2 to the 0 gives us 1, so our y value is 0. And 2 to the first power gives us 2, so our y value is 1. And 2 squared gives us 4, so 2 is our y value. And then 2 to the third gives us 8, so 3 is our y value. And so now if we want to graph this, we can just plot those points. And as we discussed with exponents, with graphs of exponential equations, we have an asymptote where we cannot cross. And in this case, our asymptote is the y-axis, right? Notice that this, if we went to the negative 2 here, it would be 1/4, negative 3, 1/8, negative 4, 1/16. It's getting closer and closer and closer to 0, but it's never going to cross it, okay? So this is our graph of y equals log 2x. And our domain is going to be all values greater than 0, x all values greater than 0. As we can see, this will keep getting negative and negative, negative, but it's never going to reach 0. And so our y values will be all real numbers, because this is going to go up, 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 up forever, and down, down, down forever. And then our asymptote is at 0. It's at the same point as our domain. All right, so one more thing here. Notice, this is, in fact, the inverse of an exponential equation, right? And so that would be y equals 2 to the x, where this is 2 to the y equals x. And so we flip our x and y value like we've spoken about and get our inverse. And so as you can tell, it is a reflection across y equals x. So it's important just to realize that we really did just graph the inverse of an exponential equation. So it gets more tricky. So those shouldn't be there yet, but that's okay. So general rules for translating, right? So these values should be familiar, a, h, and k, right? So a means scales the graph, and if it's negative, the graph flips. And b is new, but we'll remind ourselves what it is, right? The x values for our table, and we make a list of these powers, right? So we just did that for 2. Here we do powers of 3. Here we do powers of 5. And then our h is our horizontal shift, right? And so if this is a positive value plus h, it shifts it left, opposite of what it seems. And then if it's negative, it shifts it to the right. And then k, as you remember, is a vertical shift. So now if it's positive, it shifts up, and if it's negative, it shifts down. It's important to think about these so that you can predict what your graph should look like. And so now try and predict what happens to these three. And we're about to work them out on the following slides. So if we want to graph log 2x plus 3, right? This is the inverse of an exponent. So we should think about this as an exponent, right? And if we're doing PEMDAS or GEMDAS, our order of operations say that exponents comes before addition. So we evaluate this, then we can add 3. So let's start with just this function right here. All right, and so obviously we can tell right away that this is shifted up by 3. So hopefully that's what you thought on the previous slide. And so we're going to start with just the very basic here, because this isn't too hard. We've already done it. We can fill out a table here, right? 1/2, 1, 2, 4, negative 1, 0, 1, 2, 3. Okay? And next, we're actually going to add 3 to all these values, right? Because it said evaluate this, right? So we evaluated 1/2, the log of base 2 of 1/2 gave us negative 1, and that's this right here. And now we just have to add 3 to it. So if we add 3 to each of these, we get these new values, and that gives us our actual table for what we're looking to graph, right? So our x values remain the same, but our y values have all shifted up by 3, right? They've all been increased by 3, which shifts it up on the graph by 3. Okay, so now if we go graph it, we have these points. And these points aren't just some random points that I've graphed, right? I'm plotting these points. So 1/2, positive 2, 1, 3, 2, 4, 4, 5, and then 8, 6 is just about there. Not maybe. It might not be perfect there. Okay, and so then I draw my graph, and we notice again, right? It still has an asymptote at 0 because we didn't have a horizontal shift. We just had a vertical shift. And so our domain is still x is greater than 0. Our range is always going to be all real numbers. And our asymptote is at x equals 0. All right, so now what if we have an h, a horizontal shift, right? Shifted left by 2. And this is important. It says plus 2, but it shifted left by 2. And so we're going to start with the table for just log 3 of x, okay? Pretend that we have nothing going on. And so this time these are powers of 3, right? Because these are, the base is 3, so these should be powers of 3 now. So 1/3, 1, 3, 9, 27. If this is tricky for you, seek some additional help. Okay, and those are the exponents that we raised 3 to get those values. All right, so here's where it's tricky. Next, we subtract 2 from each of our x's because we shift left by 2. So we're actually modifying our x values, right? These x's relate to these y values, but what's happening is we're shifting everything left by 2. So we're reassigning the 1/3, x at 1/3 to 2 less than that is now equal to our normal y value. Notice, just this should feel comfortable. You've done this in like 8th grade or something like that. Instead of subtracting 2, I could just add negative 2. And so my new value is going to be negative 1 2/3, negative 1, 1, 7, 25. And notice these numbers get big really quick, so we can't necessarily graph all these, but it's good to check out what happens. And nothing's happening to our y values because we have nothing going on outside of our parentheses here, okay? So our new table for this graph, log 3 of x plus 2, are these values. And we'll plot those values, and this is what we get. And notice these points are kind of spread further apart because now we're doing powers of 3, not powers of 2 anymore, okay? And so we have our graph, and notice we now do have an asymptote that's been shifted left by 2, and we could have predicted that. And you could actually draw this dotted line first, and you need this line. You need to put this asymptote line because otherwise someone might infer that it could keep going this way, right? So we have our asymptote there, and what's our domain? Well, our domain is greater than negative 2. All x values greater than negative 2, right? We shifted left, so our asymptote shifts left as well. All right, one more. So here's a crazy one. So the graph of negative 2 times the log 5, x minus 1 plus 3. And so we are shifted right by 1. We have shifted up by 3 and scaled by 2 and flipped. So, oh my, this is going to be crazy. So again, let's just start with log 5 of x. All right, 1/5, 1, 5, 25, 125, okay? And we get the same exponents for those values. And notice, there's no way we're going to graph most of these. But we have this negative 2, we have a minus 1, we have a plus 3. So over here, we're shifting right by 1, so we have to add 1 to all of our x values. And now, think of order of operations. We do our exponent or inverse exponent first. We've done this, right? So we apply this value right here. And then we're going to times by 2, then add 3. Multiplication comes before addition. So times negative 2 plus 3. Okay, and we go through this. And we apply this to each of them. So we've done 3 things to modify our table. And we end up with a table that looks like this. And now we can just go ahead and graph those points. And notice, it's flipped. All right, we have our asymptote at positive 1, which means that our domain has to be greater than 1.